guys. All right, so we're on the 5.4 day one continued. This was your first assignment on Friday, the worksheet 4.4, numbers 6 to 30, every other even, 33 to 39 odds, and number 40, all from this attached handout that you guys had. All right, so I wrote down all the problems. So when I get to number 33, I'm going to need to start looking at those graphs. All right. So number 6, it says for these problems to evaluate the definite integral of the algebraic something. Use a graphing utility to verify your result. A lot of it's cut off. Of the algebraic function. That's what it was saying. Okay, so number 6. We have the integral from 2 to 7, 3 dv. Okay, so I have to raise the roof. And there's no variable there. Obviously, because it's a dv, it means that it would be a v, but it's a v to the 0 power since there's nothing there. Raise the roof, so add 1, which means we divide by 1, which doesn't change anything. So it's really just a 3v when we integrate that. But the interval is from 2 to 7. So I first need to plug in the 7. 3 times 7 is 21. Minus the 2, we got to plug in a 2. 3 times 2 is 6. 21 minus 6 is 15. Oh, not 16, 15. Okay, now before I box it, I want to verify that that's the result that I'm getting in my calculator. So I have my calculator. It's all nice and charged now. Math 9. The interval from 2 to 7 of 3. Now there's no v, so you just put dx, and we get 15. So I can box it and check. Number 10. All right, let's raise the roof. Add 1, so 2 plus 1 is a 3. Oh, those 3's will cancel. So I will have an x to the 3rd. It's already a 1. Raise the roof. 1 plus 1 is a 2, so it's going to be a plus x squared over 2. And then this one doesn't have 1, so we add 1 to raise the roof. So it's just going to be a minus 2x. I don't know why I did that. Whatever. From 0 to 3. Okay, so looking ahead, when I plug in the 0, after I plug in the 3, 0 is going to go in for all those x's, and it's going to be 0. So that's going to be nice. So really all I have to do is plug in the 3. So when I plug in the 3, 3 to the 3rd is 27. And then over here, 3 squared is 9, so plus 9 over 2, minus 2 times the 3 is a 6. And then remember, when I plug in the 0 for everything, it's just going to be 0. All right, so I'm going to combine the 27 and the negative 6. 27 minus 6 is a 21. I need to get a common denominator. 21 times 2 is what, 42? So 42 over 2 plus 9 over 2 is 51 over 2. Okay. 51 over 2 is approximately, or it is exactly 25.5. So now before I box it, let's check it in the calculator. So math 9, the interval from 0 to 3 of 3x squared plus x minus 2. Trying to read through all my handwriting there. 25.5. Check. So that did say to verify your result using a graphing calculator. All right, number 14. So we need to raise the roof, but before I do that, we need to rewrite this. We can't have this in the denominator because then it's going to be hard for us to raise the roof. So when we undrop it like it's hot, I took up my space there. I'm going to get the integral from -2 to -1 of u minus u to the -2nd power du. Okay, am I zoomed in enough? All right, now we can raise the roof. So I'm going to integrate. That's already a 1. Raise the roof, add 1. So it'll be a u squared over 2. And then minus -2, raise the roof, so plus 1. -2 plus 1 is a -1, so I'm dividing by a -1. So this double negative right here is going to make it positive. And then -2 plus 1 is a -1. I'm going to go ahead and drop that back down to the denominator. So it'll be 1 over u to the 1, or just u, from -2 to -1, and then plug them in. Let's see, -1 squared is a 1 over 2, plus 1 over -1 is a -1, minus, because now we have to plug in the -2. -2 squared is a 4, so I have 4 over 2. I should have written what that reduces to, but whatever. And then plugging in a -2 over there, 1 divided by -2 is a -1/2. Oh, I guess it's good that I kept it that way. All right, so let's see, I've got a half minus 1, so that's a -1/2. And then 4 halves minus 1/2 is 3 halves, but then I'm subtracting the 3 halves. -1/2 minus 3 halves is -4 halves. -4 divided by 2 is a -2. Okay, let's check it. So math 9, from -2 to -1 of, we can't use u, so x minus, I could type it in like this, but use parentheses, 1 over x squared, or I could type in x to the -2 power. I'm going to put x to the -2 power dx equals -2. Check. Number 18. Okay. Now this we're going to have to rewrite a little bit because we have the square root of 2 over the square root of x pretty much, because they're both underneath the radical. So I could write that separately. So the integral from 1 to 8 of the square root of 2 over the square root of x. But I need to undrop this like it's hot, because remember that's to the 1/2 power and it's in the denominator. So if I bring it up top, it'll be the integral from 1 to 8 of the square root of 2 times x to the -1/2 power. Okay. And then from there, square root of 2, that's a constant. So I can just bring that out front and not mess with it. So that could be square root of 2, integral from 1 to 8 of x to the -1/2 dx. Okay, now we're ready to raise the roof. So I'm going to add 1, but since I need a common denominator, I'm going to add 2 over 2, because that's the same as 1. -1/2 plus 2 over 2 is a 1 over 2, so I'm dividing by 1/2. So when I flip that around, dividing fractions uses pi, flip the second to multiply, that'll be a 2 times x to the 1/2 power, and it's from 1 to 8. And let's start by plugging in the 8. Now I'm going to switch this x to the 1/2 back to a square root. It's just the square root of x. So I'll put it over here. So we're going to have 2 times the square root of 8 minus, now plug in a 1, 2 times the square root of 1. Well, the square root of 1 is 1. 2 times 1 is 2, so it's a -2. 8 has a hidden perfect square inside. The square root of 4 is a 2. Bring out a 2 with the 2 that's already there. 2 times 2 is a 4. Then you're done with that. This 2, though, is stuck inside. So it's 4 square root of 2 minus 2. Okay. And let's not forget that we have this constant that was out front. I should have written it right here and I forgot to. I almost forgot about it. Okay, so let's distribute that. So square root of 2 times 4 square root of 2. So I will have 4 times radical times itself means poof, the number gets to come out. Minus square root of 2 times -2 is a -2 square root of 2. So I'm going to have 8 minus 2 square root of 2. All right, what is that as a decimal? Let's find that first. 8 minus 2 square root of 2 is 5.17. So I'm just going to put that in parentheses here, because this will be our answer, right? But when we check it in the calculator, it's not going to give it to us in that format. It's going to be given to us in decimal format. So when we check it, I need to know what the decimal is. All right, so math 9 from 1 to 8 of, I'm just going to type it in like the original, the square root of 2 over x dx. Look at that, 5.17. It checks out. I like it when we can check our work as we go, because then we can catch our mistakes or figure out if we did it right or wrong. And even if you get stuck and can't figure out what you did wrong, you know that you need to watch my homework video to see where you went wrong at. Okay, so that's an important learning thing there. All right, number 22. We have the integral from -8 to -1 of x minus x squared over 2 cubed root of x dx. We need to rewrite this. And I didn't realize I wasn't focused. And I'm gonna zoom in a little bit too. Okay, so I need to bring that denominator out. Okay, so here's what I'm gonna do. I'm gonna split this. I'm gonna make this the integral from -8 to -1 of, I'll have x minus x squared over 2. That's this part, x minus x squared over 2. But then times 1 over, and I'm going to rewrite that cubed root of x as x to the 1/3 power, because that's what it is. Okay, and then I have to undrop this like it's hot, bring it to the top. So I will get the integral from -8 to -1, scooch this over, of x minus x squared over 2 times x to the -1/3 power dx. Okay. All right, now I am ready to, I still have one more step. This is still not cleaned up yet. I need to distribute that x to the -1/3 power, okay? But before I do that, it's gonna be hard to do that with this fraction. So this is really a 1/2, right? That would be a constant. So let's bring that constant out in front of the integral. And let me write it a little bit bigger too, because it looks really sloppy that small. So I'm gonna put it over here. So this is the integral. I still have not integrated it yet, from -8 to -1. Oh, I forgot to put the 1/2 out front. 1/2, and then we have x minus x squared times x to the -1/3. So this one was a doozy. This is why Mrs. Ardito had a bad word written on the worksheet describing this problem. Anyways, so, dx. So let's go ahead and distribute. Remember, when you multiply like bases, you add the exponents, okay? So this will be, I have a 1/2 out front, integral from -8 to -1, x to the first times x to the -1/3 is really the 1 plus a -1/3. 1, we can make it a 3 over 3. 3 over 3 minus 1 over 3 is 2 over 3. So it'll be x to the 2/3 power, minus, because it's negative. Power to power, or like bases being multiplied, you add the exponents. So 2 minus 1/3. Well, I can write this as, let's see, 6 over 3, because 6 divided by 3 is 2. So 6 over 3 minus 1 over 3 is 5 over 3 dx. Okay. All right. So I haven't even integrated it yet. That was all just rewriting it so that I can integrate it. Let me zoom out just a little bit. Okay. So now I'll start integrating. Let's not forget that 1/2 is out there. Okay, so I got to raise the roof. So plus 3 over 3, that would be a 5/3. So I'm dividing by 5/3. When I flip that around, because dividing fractions is easy as pi, I'll get 3/5 x to the 5/3 minus, raise the roof, 5/3 plus 3/3 is 8/3. So I'll have divided by 8/3, flip it, you'll get 3/8 x to the 8/3 from -8 to -1. Okay, yeah, this one is a doozy, that's for sure. I'm gonna bring the work up here. I'm going to change colors every time I do a step on this one. Okay, so there's a 1/2 out front. Let's not forget that that's there. All right, when I plug in a -1 for x, this is 3/5 times, remember what 5/3 represents. The 3, it means it's a cubed root of x to the 5th. So it's the cubed root of -1 to the 5th power. -1 to the 5th is still -1, so it's the cubed root of -1. I'll just write it like that for right now. Minus 3/8 times the cubed root of x to the 8th. So when I plug in a -1, -1 to the 8th power is a +1 because it's an even numbered exponent. So it's the cubed root of 1. That's just the first part. Now we've got to plug in the -8 to everything. So here it gets a little trickier. We got to plug in a -8 for x, and it's a cubed root. So I think I can squeeze it in there. So that would be 3/5 times the cubed root of -8 to the 5th. So I'm going to use my calculator for this next part. -8 to the 5th, it's going to be a negative number. So let's see what the cubed root of that number is. So I'm going to hit math 4 to get a cubed root, and I'm just going to type in -32768, and I get -32. So that's times -32. So I'm using my calculator for that part. All right, minus 3/8 times, now I've got to plug in a -8 into this one. So remember, it's cubed root of -8 to the 8th power. Now a negative number raised to an even power is going to make it positive. So, and just to show you that, -8 to the 8th power is a positive number. But now let's take a cubed root of that. So math 4 of 16777,216, and I get 256. So Mrs. Ardito was not lying when she said that this problem was a bad name. Okay, let's clean this up. So I'm going to use a different color. So we still have the 1/2 out front, and I've got the cubed root of -1. The cubed root of -1 is still -1, so this is a -3/5. The cubed root of 1 is 1. 1 times -3/8 is a -3/8. So I'm going to need to get common denominators on that in a little bit. Minus 3/5 times -32. So I'm just going to multiply the 32 times 3. I get 96, so that's a -96/5. Minus the 3/8 times 256, so it'll be over 8, and I just multiply 3 times 256, you get 768. So yeah, we've got to get common denominators. It looks like that's going to be a 40. So to get 40, I'm going to need to multiply this one top and bottom by 8, this one top and bottom by 5, this one top and bottom by 8, this one top and bottom by 5. Okay, so I still have that 1/2 out front. So -3 times 8 is a -24. Minus 3 times 5 is 15, so minus 15. So that'll be a -39/40. It's getting smaller. Minus, all right, let's figure this one out. 96 times 8 is a -768. So I'm going to multiply that, or I'm just going to write negatives because it's negative. It's a negative in front. All right, and then minus 768 times 5 is 3840. Remember, it's -3840. So -768 minus 3840 is -4608 all over 40. All right, I'm going to switch colors before I do the next step. Negative next to negative changes these to a positive, and these are common denominators. So basically 4608 minus 39. 4569. Yep, this problem sucks. It really does. Times 4569 over 40. Okay, well then when you multiply straight across, we'll get 4569 over 80. Ugh. That better be it. As a decimal, it's 57.11. Okay, so let's check it in our calculator. Woo! All right, math 9. From -8 to -1 of, let's see, I'm going to need that numerator in parentheses. So that'll be x minus x squared, close parentheses, divided by, I'm going to use parentheses because I've got 2 items here also, 2, and then I need to hit math 4 for the cubed root of x. Scroll to the right, close that parentheses, dx. And there it is. Check. Yeah, that one definitely was a doozy. Way worse than the one that we did for warm-up. Way, way, way worse. Number 26. I think I wrote 24 first. Yeah, because it's every other even. 26. So the integral from 0 to pi over 4 of 1 minus sine squared over cosine squared d theta. So when I saw this, I was like, wow, that looks familiar. So back in Enhanced Math 3, you guys learned that sine squared plus cosine squared equals 1, right? So that means that they would subtract the sine squared from both sides, and cosine squared would equal 1 minus sine squared. So I'm going to substitute that 1 minus sine squared with the cosine squared because it's an identity. So this will be the integral from 0 to pi over 4 of cosine squared theta over cosine squared theta. I'm sure you can tell what's going to happen next. These cancel, so that's just a 1. So the integral from 0 to pi over 4 of just 1 d theta. All right, let's integrate it. This one is way easier than it looks. So it doesn't have a theta, it's a theta to the 0, and then we gotta raise the roof, so it's just theta. But from 0 to pi over 4. When you plug in the pi over 4, you get pi over 4. When you plug in the 0, you get minus 0. So it's just pi over 4. Now let's check that. Pi over 4 is 0.7853. Let's do math 9. Integral from 0 to pi over 4 of, let's put 1 minus sine, I think it's of x squared. Oops, I didn't mean to close out of there. And then divided by cosine squared theta. So cosine of x squared. I think I typed in something wrong. Let me go back. Well, nope. I went ahead and I'm like, okay, what did I type in wrong? I was having trouble typing this in correctly, so I typed in its simplified form, which was just the 1 d theta. So integral from 0 to pi over 4 of 1 dx, and I get the same thing, the 0.78. I think I got up here. Oh, I think I erased it. But yeah, pi over 4 is the 0.7853. So it checks out. All right. Number 30. Integral from negative pi over 2 to pi over 2 of 2t plus cosine t dt. All right, let's integrate it. It's ready to go. Let's raise the roof. It's already a 1 plus 1 would be a 2. Those 2's would cancel, so it would just be a t squared plus the antiderivative of cosine. Well, what derivative gives you cosine? Well, the derivative of sine is cosine, so when we undo the derivative, find the antiderivative, that means it was sine of t. From negative pi over 2 to positive pi over 2. All right, let's plug in the pi over 2. And we will get pi over 2 squared would be pi squared over 4. plus sine of pi over 2 minus, plug in a negative pi over 2. Negative pi over 2 squared would be pi squared over 4 again, plus, because the negative number squared is positive, plus sine of negative pi over 2. Okay, what is the sine of pi over 2? Well, pi over 2 is up here. I know my circle sucks, but that's okay. That's the 0.01. Sine is the y value, so the sine of pi over 2 is a 1. So this is really pi squared over 4 plus 1, okay, minus pi squared over 4 plus the sine of negative pi over 2. Negative pi over 2 is going clockwise down. Remember, counterclockwise is positive, clockwise is negative. So negative pi over 2 is down here, and that's at the coordinate 0, negative 1. So the sign would be negative 1. Okay. So let's go ahead and distribute this minus sign. So it would be minus pi squared over 4, negative times negative is positive 1. And then we'll have pi squared over 4 plus 1. Hey, pi squared over 4 minus pi squared over 4, those cancel out to 0. 1 plus 1 is a 2. Let's check it. Math 9, from negative pi over 2, oops, went too far, to pi over 2 of 2x plus cosine x dx. 2. Checks out. Yay, that was number 30. Oops, I dropped a pen. Oh well. All right, number 33. Okay, so now I got to look at these graphs. All I need from the graph, because I'm determining the area, is I obviously can't find the area of that curve because I don't have a formula for that. So all I need from the graph is where it starts and stops. So it's from 0 to 1. So it's that interval of that function that they gave me. So I have the function that they gave me written down, x minus x squared, and I know it's from 0 to 1. So I have my integral all ready to go. I just have to integrate. So I'm going to raise the roof. So 1 already, add 1, divide by 2. So it's going to be x squared over 2 minus, raise the roof, divide by 3. It'll be x cubed over 3 from 0 to 1. Plugging in the 1, 1 squared is 1, so it's just going to be 1/2 minus 1 cubed is 1, 1/2 minus 1/3. And then when I plug in the 0 to both of those, it's going to be 0. So that's going to be nice. I need to get a common denominator. It's going to have to be a 6. Multiply that top and bottom by 3, that top and bottom by 2. So I'll have 3 over 6 minus 2 over 6 is 1 over 6. And that's it. Number 35. Looking at the graph, I know the interval is from 0 to 3 because of the graph. Goes from 0 to 3 of that function. Okay. So for this one, I do need to rewrite this because I first need to rewrite that square root of x as x to the 1/2 power. So I'm going to start off by doing that. But that still is too messy for me to integrate. So we need to distribute it now, because you don't do chain rule with the antiderivatives, at least not on these. So, and we don't know how to do that yet. So we'll have, let's see, 3 times x to the 1/2 would be 3x to the 1/2 minus x times x to the 1/2. Remember, this is a 2 over 2 because it's to the first power. 2 over 2 plus 1 over 2 is 3 over 2, so it's x to the 3/2 dx. All right, now we can integrate. So I'm going to raise the roof. I'm going to add 2 over 2 since that's the same as 1. I need a common denominator. 1 over 2 plus 2 over 2 is 3 over 2. Add 1 over here. That'll be 5 over 2. Remember, we got to flip it around when we multiply. So it'll be 2/3 x to the 3/2 minus 2/5 x to the 5/2 from 0 to 3. What's nice about the 0 that we're going to plug in the future is it's 0, so that's going to be nice. Okay, so plugging in a 3, remember that 2 in the denominator of that exponent means it's a square root. So this is 2/3 times the square root of 3 cubed. 3 cubed is 27, so this is the square root of 27. I'll leave that there for right now. Minus 2/5 times, plug in a 3. Remember, that's a square root of 3 to the 5th. What is 3 to the 5th? 243. And when we plug in a 0, it's just going to be all this minus 0. So it's not going to matter. Okay. All right. Can we go further? Well, 27 is 9 times 3, and 9 is a perfect square. 243, I think, because there were 5 3s, there should be an 81 in there. Let's divide it by 81, because 81 is perfect square. Yeah, 81 times 3. Okay, so just cleaning this up. The square root of 9 is a 3. A 3 will get to come out. We use a different color to show that. And when that other 3 comes out, it's going to cancel with the 3 in the denominator that's already out there. So it'll be 2 square root of 3. Minus, the square root of 81 is a 9, so a 9 gets to come out. Well, nothing canceled there, it's just an 18/5. This 3 stuck inside, square root of 3. Okay, let's get common denominators. So I'm going to need to multiply top and bottom by 5. So that'd be 10/5 square root of 3 minus 18/5 square root of 3. 10 minus 18 is a negative 8/5 square root of 3. Yeah, I think. Was it a 2/3? Yeah. Okay. Oh, I messed up somewhere. So up here, when you flip around the 2/3, these 3's cancel. So it should have just been a 2 in front, not a 2/3. So when we multiply by 3, that makes this a 6. So then 6 times 5 would be 30. 30 minus 18 is a 12. So it should be 12 square root of 3 over 5. So I messed up there a little bit. But when you check it, it will work out when you use your calculator. All right, number 37. It's just the arithmetic that throws us off. Like I said, on the AP test, though, like they're not going to give you problems where you're going to get hung up on the arithmetic. They're testing you on the calculus part. All right, number 37, y equals cosine of x, and according to the graph, it's from 0 to pi over 2. Okay, and this one is ready to go. So when we integrate it, let's see. The antiderivative of cosine, well, what derivative gives us an answer of cosine? Well, the derivative of sine is cosine, so the antiderivative would be sine from 0 to pi over 2. This one's actually pretty easy. So you'll have the sine of pi over 2 by plugging in that, and then minus the sine of 0. Sine of pi over 2 we know is a 1. Sine of 0 is 0. 1 minus 0 is 1. That one wasn't bad at all. Nice, easy one. Number 39, 3x squared plus 1. And they give us x equals 0, x equals 2, and y equals 0. They didn't give us a graph on this one. So basically what this means is the x equals 0 to 2, this is our interval. The y equals 0, this tells us it's within reference to the x-axis. So we're finding the area under the curve, which means that we are integrating. Okay, and the directions do say, find the area of the region bounded by the graphs of the equations. So we know that we're finding the area, so we know that we're integrating. So we need to draw a picture. So I'm going to draw a picture. I know it's from 0 to 2. Okay, and let's plug in numbers. So if I plug in a 0 for x, wipes out the 3, is just 1. So 0, 1. If I plug in a 1, 1 squared is 1. 1 times 3 is 3. 3 plus 1 is a 4. So 1, 4. If I plug in a 2, 2 squared is 4. 4 times 3 is 12. 12 plus 1 is 13. That's way off my graph. So I know that it's going to be up here. We'll pretend that that's 13. So 2, 13. And it is a parabola, so this has more of a curve than my dinky graph shows. Okay. So the area they want is this, which we don't have a formula for that because it's not a triangle, because this is a curvy, it's not a straight line, it's a parabola. So it's the curve of that parabola. Okay. All right. So I know that this is what I'm looking for. And so it's the integral from 0 to 2 of 3x squared plus 1 dx. And let's integrate. So I'll switch colors. Raise the roof, so plus 1 would be a 3. Those 3's will cancel, so I'll have an x to the 3rd. Raise the roof there, it'll be plus x from 0 to 2. Plug in the 2. 2 to the 3rd is 8. 8 plus 2 is a 10. Minus, when you plug in a 0, it's just going to be 0. So the answer is 10. And you could check that in your calculator too, and you'll get the same thing. That was 39. Whoop, whoop. Last one. Sorry this one's so long, but like I said, for these homework videos, where's my last one? If you need to fast forward because you understand a problem, you have specific ones you're looking for, then you can always do that because it's not an ed puzzle. All right, number 40. So same type of thing. I could draw a picture, but I don't really need it. So I know that this is the integral from 0 to 4. And it's of 1 plus the square root of x dx. And we need to rewrite it. So integral from 0 to 4 of 1 plus x to the 1/2 dx, because now it'll be easier for us to raise the roof. Raise the roof right here, we'll just get an x plus raise the roof here, we'll get 3/2. Flip it around, we'll get 2/3. Nothing cancels this time. X to the 3/2. And it's from 0 to 4. Okay, so start by plugging in the 4. So we'll get 4 plus, plug in the 4 here. This is the square root of 4 cubed. Let's just try it. The square root of 4 to the 3rd is 8. Nice. Don't you love calculators? So it's 2/3 times 8. Minus, when we plug in a 0 to both parts, it's just going to be 0. Don't you love it when that happens? I like seeing a 0. All right, let's see. This will be 4 plus 2 times 8 is 16/3. Got to get a common denominator. 12 plus 16 is what, 28? So this will be 28/3. And it does work. All right, that's it. I hope that helped. Bye, you guys.